So let's take a look at how the computer does recognize such expressions, or how it recognizes these conditions. So a logical or Boolean expression is simply an expression that is either true or false. Now, we've talked about expressions before, like an integer expression or a double expression that evaluates to an integer or double. So now we're taking a look at expressions that evaluate either to true or false. And the values true and false themselves are what we call logical or Boolean values. So let me give you an example. So let's say I have I is greater than j. This is a Boolean expression because it's going to evaluate to either true or false. So this would be true if the value of I is greater than the value of j, and if I is not greater than j, so if it's less than or equal to j, then this expression would be evaluated to false. A relational operator is an operator that allows us to make these kinds of comparisons in a program. So using our previous example, the greater than symbol is a relational operator because we're comparing I and j. So these operators, as I said, they let us make comparisons. So any symbol that lets us do that would be considered a relational operator. Now, there are 6 different relational operators that we're concerned with. The first is equals to, which is denoted by 2 equal sign. So if I want to check if two values are equal to each other, I can say something like x double equals y. I can also check if two values are not equal to each other. So that's denoted by using an exclamation point and then an equal sign. So I can do x exclamation point equals y. And then the others are pretty straightforward. Less than just means we use the less than symbol, so we can check if x is less than y. I can use a greater than operator, which is the greater than symbol. So this can check to see if x is greater than y. I could do less than or equal to, which is the less than sign, but then we tack on an equal sign immediately afterwards. And then there's the greater than or equal to operator, which is the greater than sign, and then we tack on the equal sign right afterwards. Each of these operators let us compare the two expressions. So like for example, if we want to check if two values are not equal to each other, I can just do x not equals to y. So this will return true if x is not equal to y, and it will give me false otherwise. Now for equality, I want to make sure we're very clear that we need to use 2 equal signs. We need to use double equals, 2 of them, as in 1, 2, both of them. Because what would happen if we try to do a single equal sign? What if I try to do something like x equals y? Would that check for equality? Not quite. This is our assignment statement. Remember, so what this is saying is I take whatever is in y and I store it in s. And the way it's programmed is it's designed to always evaluate to true. So even if x and y have 2 different values, x equals y will always evaluate to true. So we got to be really careful with that. So if you want to check for equality, you have to use double equal sign. It's a very common mistake among students. So I'm just telling you right now, make sure you get in the habit of using 2 equal signs if you want to check if 2 variables are equal to each other. What's great about these relational operators is we can use them to directly compare integers and floating point data types. So let's take a look at a couple of examples. So I can evaluate to see if 8 less than 15 is true or false. So I mean, obviously 8 less than 15 is going to be true. So I take that expression, evaluates to true, because sure enough, 8 is less than 15. I can check for non-equality. So I can check to see if 6 does not equal 6. Well, that's not true. 6 does equal 6, so this would evaluate to false. And I can even do floating point values. So I can check to see if 2.5 is greater than 5.8. Sure enough, that's not true, so this is going to evaluate to false. Now, if we want to compare character values, we need to use the collating sequence of the Unicode character set. So we take each letter, we map it to its collating sequence, and then we do the comparison. So for example, let's say I want to compare a blank space with the letter A. And I want to see if the blank space comes before the letter A. Well, we would map the collating sequences. So the blank space corresponds to 32. The letter A corresponds to 97. So since 32 is in fact less than 97, then blank space less than A is in fact true. Now, what about something like this? What if, so here 8 is an integer, not a character. So I'm trying to compare the number 8 with the character 5. Well, remember, 5 is a character. So we take a look at the Unicode number for it, which is going to be 53. So here, this expression would actually evaluate to true. So here's that very rare case where you can tell your friends 8 is less than 5, and here is why, using collating sequences.